Now, just like we can expand a log, we can also condense that log and put it back together. So it's good to know the properties. It's really just helpful to be able to go back and forth between different forms. Sometimes when we're evaluating or trying to simplify, one form is more helpful, or when we're solving, again, one form is more helpful. So we need to go back and forth just so we can simplify as much as we can sometimes. So here we're going to go with the other direction. So I have two logs that are written separately, and I want to write them as one log now and put that back together. Notice that I have a plus sign in between. And remember that the plus sign, the addition, refers to the original log being multiplied. And you do want to make sure that your logs have the same base. If your logs don't have the same base, then you cannot combine them right now. So I have log 4. Again, that plus sign means I'm going to put it back together using multiplication. So I have 2 times 32. I take the two arguments that are here and here, and I multiply them inside that log. 2 times 32 is 64. Now this one happens to be one that I can simplify further. So if you're evaluating logs, again, remember you're looking, I'm just going to use x here for my variable. You're looking for that exponent in this case. So we're saying, well, 4 to what power would give me 64? And the answer here is going to be 3. So 4 times 4 is 16, times 4 again is 64. So our answer here is 3. So what this means is that log 4 of 64 actually just simplifies to a final result of 3. So in this case, being able to put those logs back together actually let me simplify a lot more easily. Whereas in other examples, kind of taking them apart, let me simplify, part of that log. Let's do another one. So here I see subtraction. So when you see subtraction, remember that means the original log had division in it. So I have the same base, both are log base 10. So whatever comes first is in the numerator, and then whatever comes second is in the denominator. So I have log base 10 of 4x minus 3 over x. Now, there's nothing I can do here. If I could simplify this fraction, I would, but I really can't here. So this is going to be my final answer. All right, let's do a couple more with the same sort of strategies here, kind of putting them back together as a single log. And we're just kind of getting a little bit more complicated here and there. So bringing in more properties, more steps. And you really just want to take your time. So here I have a 1/2 log x plus 4 log x minus 1. If there's no base written in, remember it's base 10. So these do have the same base, which means that it is possible for me to put things back together. Now, this one's a little bit harder because I do have these extra coefficients out front. And when I have those coefficients out front, they refer to powers. Remember in the last video, we took those powers and we brought them out front. Now we're going to reverse that process. So I want to bring that power back on the x, and I want to bring that 4 power back on the x minus 1. Okay. Now, x minus 1 is in parentheses, so when I put that power back on, I'm going to make sure I clarify that 4th power is going to all the x minus 1 part. Now, remember here that addition means multiplication, so I'm going to, again, keep making this kind of smaller and smaller, putting things back together. So I have x to the 1/2 times x minus 1 to the 4th power. So putting those two arguments right together and using multiplication there. And then I would see if I could clean it up a little bit. So if these were all the same factor, then I could, kind of clean it up and combine my powers. But there's not really much I could do. The only thing I could do is maybe write this as a square root of x if I wanted to. But your book leaves it as 1/2, so I'll leave it as 1/2. So it's just x to the 1/2 times x minus 1 to the 4th. And again, that's really kind of all we can do here. Let's try the next one. So here I have the natural log function. So I have the same kind of log. They both have base e. And if I have coefficients out front, I do want to bring those back first and remake those into those powers. So you do want to do that before you actually start multiplying or dividing. Now I have that subtraction here. Remember, subtraction refers to division in the original form. So I have my x plus 7 cubed being divided by x. Whatever comes first goes in the numerator, whatever comes second goes in the denominator. And here, again, I really can't do anything else. So I'm done. If I could simplify in here, I would. I use parentheses. Your book sometimes will use brackets here. So if you see brackets here instead, that's also fine. Either way is correct. All right, let's do one more. So here, this one again, I'm getting really complicated. So let's think about this first. When you're going back to the single form, start with the powers. And even the other way, notice like you have to kind of be careful about the order that you go in. So when we're reversing that direction, you want to start with those powers first, whereas in the other way, we kind of split things first before doing the powers. So it really just depends on the problem. So here I want to put those powers back on. So I have log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2. And do notice that all my bases are the same, which is really nice. It makes things a lot easier here. Right, it actually allows me to combine them together. A couple things I'm going to notice. I see subtraction twice. So a good tip here is when you're trying to condense that log is to factor that negative part out. 6 squared I can write as 36. And then I just have that negative piece kind of factored out here. This is actually going to be similar to the example we did in the last video, going the opposite direction, where we had a more complicated denominator. So when you have a more complicated denominator, you have that subtraction twice because you distribute through. So again, we're reversing this process. I'm going to take that subtraction back out so I can write it like this, and I'm going to start putting that piece back together first before I rewrite the division. So I want to combine this back together first. I see plus sign, so that's going to be a multiplication. Times y to the 1/2. And then now I can deal with the subtraction, which means division. So I have log base b. I have x to the 4th in the numerator. And then I have 36y to the 1/2 in the denominator. So if you have a double subtraction like this and you're trying to put that log back together, then basically you have more than one thing in the denominator. So you're not doing any complex division in the sense of like dividing fractions and fractions, but if you have different subtractions here, then that means you have two different parts that are in the denominator. So we're putting that back together. So this is basically as far as I can really go. Again, the only thing that you could do different if you wanted to is you could write that y as a root instead. So this is perfectly fine. This is also fine. So you just want to read how the problem wants that final answer to be written. But our fractional exponents and roots are interchangeable.